What up, math, please? Whoop, whoop. Let's get into this. All right, here's the warm-up. Go ahead and identify the next 3 terms in each pattern. Ready, set, go. All right, you should probably pause it because you need more time, but I'm going to get rolling. Let's do this. So that's what? Plus 3. Oh, then we go backwards. Minus 1. And then plus 3. And then minus 1. And then plus 3. Minus 1. Plus 3. Oh, I see the pattern. Then it's going to be minus 1 is 3. Plus 3 is 6. Minus 3 is 5. Or minus 1 is 5. Perfect. What is this one? That's 1. That grew by 2. That grew by 3. Oh, 4, 5. So now it's going to grow by 6, right? So it's going to go to 21. And then it's going to grow by 7, which is 28. And it's going to grow by 9, or 8. I'm sorry. Let's see, 6. 6 to 21. 7 to 28. And then we're going to grow by 8 to 36. Boom. Sorry, I had to get myself on track. 8 plus 1, 8 plus 4. Okay. So this is plus 3, right? We're adding in 3. And I want to put that plus in there, I guess. And then this is plus 5. Because 4 plus 5 is 9. Oh, so it went plus. Okay, so we added. If we start out with A over here, it would have been plus 1, right? And then 3, then 5. So we're going to add 7 to get to A plus 16. Then we're going to add 9 to get to A plus 25. And then we're going to add 10 to get to A plus 35. Boosh. No, we wouldn't add 10. We'd add 11. What am I thinking? 36. Because it should be, right? Plus 7. Plus 9. And then plus 11. There we go. All right, 3D minus 1. 4D minus 2. Okay, this is going up by 1 each time, right? 1, 1. And this is going minus 1 each time. Minus 1, minus 1. So it should then be 6D minus 4. 7D minus 5. And 8D minus 6. And our last one, after knee surgery, Josh's doctor starts him on an exercise program. She suggests jogging for 12 minutes per day for the first week and increases that time by 6 minutes per day each week after that. All right, the first 3 terms of this pattern. How many weeks will it be before Josh is jogging 16 minutes a day? Well, he started out at 12, and he's going by 6 minutes, increasing that by 6 minutes per day each week after that. So that's 12, and then after that's after the first week, it's gonna go to 18, and then 24, and really, let's see, 30, 36, 42, 48, 54, and 60. So, if I'm reading this right, I can't really tell the way it's reading. Is he going up 6 minutes per day extra, or is it he's running an extra 6 minutes, like every week he's going to up by 6 minutes, then every day he's going to run that total? I think it's what it's going to be. So, I would say this is week 1, 2, 3, 4, 5, 6, 7, 8, 9 weeks later. He should be there. All right, let's see how I did. You ready? Those are my answers. Pause if you need to. And I want to roll down. I want to see, especially on this one. Yeah, 9 weeks. Perfect. I was right. Awesome. Boom. All right, let's move on with this bad boy. Okay, sequences are very common throughout nature and our everyday lives. Arithmetic sequences are a specific kind of sequence that results from adding the same number to each term to find the next term. And it should be said it can be adding or subtracting, right? Because you can add a positive or add a negative, right? So look at the triangle structure that composes the Nima Sand Museum in Japan. The top row is one triangle, the next row is three triangles, then there are five, so it goes 1, 3, 5, 7, actually count it, 9, 11, 13, right? Okay, it's pretty awesome. Similarly, the pyramid of oranges at London's Tate Gallery shows an arithmetic sequence. By counting oranges in each row of one face of the pyramid, we can see the sequence 1, 2, 3, 4, 5. Wow, that's crazy. So 1, 2, 3, 4, 5. Yeah, it's just going up by one each time. Awesome. So there are a lot of sequences everywhere. You'll find that in nature. There's just sequences are the thing. Okay, for today's vocabulary, let's get this written down, and I'll just have you, I'm going to talk about it, then I'll have you pause it if you want to. So we have a sequence is a list of numbers in a specific order, right? There's a pattern. A term of a sequence is a number in a sequence. So if I have a sequence like the last one's 1, 2, 3, 4, 5, each of those numbers is a term. Arithmetic sequence is a pattern in which each term after the first is found by adding a constant, the common difference d. So we call that common difference d. And I know difference usually means subtraction, but not always in this case. It could be addition or subtraction to the previous term. The common difference is the difference between two consecutive terms in an arithmetic sequence. All right? So although we're adding, when we find the difference, we're subtracting two terms, and it could be a positive or a negative that you get. All right, pause it, write those down, let's roll. Oh, I'm tired. It's about time for vacation. All right, y'all. A sequence is a set of numbers that are ordered in a specific way. Each number within a sequence is called a term of a sequence. A sequence in the table shows the number of course members in each row of risers on the stage. So in row 1, there's 7. Row 2, there's 9. Row 3, there's 11. Row 4, there's 13. If there was a row 5, clearly this is going, the common difference is plus 2, right? It's going up by plus 2 each time. So row 5 would have 15, right? Notice that in each term, basically we're looking for the common difference. If we look right here, I just want you to look at this example, and please do write this example down. You don't necessarily need to draw it super perfect, just write down 12, 17, 12, 17. We see that each one is changing by minus 5. That's the common difference is minus 5. Down here, from negative 13 to negative 5 to 3 to 11 to 19, it's adding 8 each time. It's constant. It's a common difference. That's why it's called common. They share it in common. Okay? Kind of busting through these. You can pause if you need to look at them. I like sequences. I like them because they're not too terrible. I mean, some of these, like B, are pretty rough, but we'll get through it. Okay, determine whether each sequence is an arithmetic sequence. Justify your reasoning. Let's look at this one. 7 to 14 is minus 3. 14 to 10 is minus 4. 10 to 7 is minus... See, that's a difference. And I see the pattern. Minus 4, minus 3. But it's not common. Look at this. So we have minus 3, minus 4, minus 3 again, minus 4. So what do we know? Is it a common difference? No, it is not a common difference. So it is not a sequence. It's not an arithmetic sequence, okay, because it's not a common difference. Let's look at this one. This one's harder to tell, going from 3/2 to 3/4. But if we put these all in a common denominator, so I'm going to put them all as 4. So this is negative 6/4, negative 3/4, 0, 3/4, and then 3/2 is really 6/4. Now we can tell there's something going on. Look at that. I added 3/4, added 3/4, added 3/4, added 3/4. So the common difference is 3/4. So if you're working with fractions, you got to put them as a common denominator. And we can see that right here. Maybe. I got to undo this. Ready? Again, plus 3/4, plus 3/4. You're just going to see that continue. So, good stuff. So that is an arithmetic sequence because it's a common difference. Identify arithmetic sequences. Determine whether each sequence is an arithmetic sequence. Justify your reasoning. What is a common difference? Well, negative 1 to negative 2 is minus 1. Negative 2, negative 4 is minus 2. Negative 4, negative 8 is minus 4. It doesn't have a common difference. The sequence is not an arithmetic sequence because it does not have a common difference. Just saying. Let's look at this one. Grows by 1, grows by 3, grows by 5, grows by 5, and then 7. Wow, it's grown by odd numbers, right? So it does not have a common difference. The sequence is not an arithmetic sequence because it does not have a common difference. Let's look at this one. Negative 5.25. 1, so that changed by negative 6.25, or that added 6.25. Oh, and look at that. 1 plus 6.25 is 7.25. 7.25 plus 6.5 is 13.5. So this is growing by 6.25 each time. The sequence is an arithmetic sequence because it has a common difference. There we go. I gotta go up and reset this because when I come teach it, when we come back after the break, I'll never remember. Awesome. Determine the next 3 terms of the sequence. Okay, so let's look at this. It goes 11, 7, 3, negative 1. So 11 minus 7 is 4. 7 minus 3 is 4. 3 minus negative 1 is 4. Okay, so that's a difference of 4 each time. So then it would go down to, find the common difference. It is minus 4. We're subtracting 4 each time. We got it? All right. Add the next common difference last term. So what's it going to end up being? Minus 4 is going to get us to minus 5. And then that's going to, minus 4 is going to get us to minus 9. Okay, sorry, I kind of spaced out there for a minute. I'm telling you, man, I'm getting tired. We got it. Let's do our last one there. Minus 4 again. What's it going to be? It's going to be negative 13. Boom. Awesome. So that is how you find the next 3 terms in a sequence when asked to do so, which you get asked to do that a lot. I don't know why they arbitrarily picked 3. Maybe 3 is a magic number or something. Awesome. Well, let's look at common difference. You can use tables to help you out here too, guys. So we can use this table to kind of explore. Let's look at this. Every time we feed the cat, it takes away 3/4 of a cup of food. So watch what happens. Feed the cat on day 1. On day 1, there's 12 cups of food, but then you feed the cat, and now on day 2, there's 11.25. Day 3, there's then 10.75. So we're going to feed the cats. So each day we're feeding the cats. What you find is after what? On day 17, you're going to run out of food. So on day 16, we have 0.75 cups left, and then the next day we're going to run out of food. So interesting. And that linear sequence is showing this to us, okay? All right, tomorrow we're going to look at arithmetic sequences as functions. So with that said, peace out.